Hey Chem Kids, Campbell here. In video 1 in chapter 19, we're going to talk about oxidation reduction reactions. Grrr. So what is an oxidation reduction reaction? Well, it's one that involves the transfer of electrons between elements or compounds in a reaction. So if electrons are being transferred, that means somebody's gaining electrons. And if they're gaining electrons, we call that reduction. Well, that seems weird, right? If I gain something, I'm being reduced. But remember, electrons have a negative charge. And so if you look at this example, you can see why they call it reduction. Here's copper plus 2. It gains an electron and becomes copper plus 1. So that charge was reduced because electrons are negative. And in fact, if we write one of these little half reactions, we can see that the electron is on the left side of the equation because I'm gaining it. So it's a reactant. We actually also have another name for the thing that is being reduced. We call it the oxidizing agent because it's the agent that causes the other one to be oxidized. Because if I'm reduced, I'm gaining, and I got to get them from somewhere. So oxidizing agents are the thing being reduced. So what's oxidation? Well, that's the opposite. So some atoms have to lose electrons, right? You can't gain them unless they're coming from somewhere. So the ones that are the losers of electrons undergo what's called oxidation. And so you can see here that if I lose electrons, I'm losing negative charge, so my charge is actually getting bigger. Here I went from potassium without a charge to potassium plus 1 plus an electron. And notice that the electron is on the right side of the equation because I'm losing it in the reaction. So gain electrons, reduction. Lose electrons, oxidation, and of course, we've got another agent here. This is also something that undergoes oxidation is called the reducing agent. It is the agent of change, so it is causing reduction in the other thing. So it's called the reducing agent, but it's the thing being oxidized, so don't mix those two things up. Now, oxidation reduction reactions, you will see me abbreviate them as redox reactions because it's easier to write redox than oxidation reduction reaction. They occur together, right? In order for something to lose, there has to be something to be gained. So the number of electrons that are gained by that thing being reduced have to be equal to the number that were lost by the things that was oxidized. So the number of electrons have to be equal. They can't just go off into space. Now, you need to be able to recognize what is oxidized and what is reduced. So we have a couple little things here to help you remember them. One is oil rig, and I will tell you, I don't really use this one, but some people like it. Oil rig stands for oxidation is loss, right? It's the loss of electrons. And reduction is gain, or the gaining of electrons, so oil rig. Now, when I was in high school and in college, I used Leo Gur. So when I lose electrons, I'm oxidized, and when I gain electrons, I'm reduced. So if you ever ask me a question in class, is this oxidized or reduced, you'll hear me saying lose electrons, oxidized, or gain electrons, reduced. So that's one I use, but you choose, whichever works best for you, or make your own. Now, how do you tell, right? If you're going to have to tell if something was oxidized or reduced and learn those little acronyms, then how do you do that? Well, in order to do that, we have to assign every atom what's called an oxidation number, and that oxidation number tells us the charge. And if we assign every atom a charge on the reactant side and the product side of a reaction, then we can look at how does the charge change. Does it become more positive? Lose electrons, or does it become more negative, gain electrons? So what? Well, in order to do that, we need to learn some rules. All right, so there are 6 rules for assigning oxidation numbers. The first one is that anything that is combined with itself or by itself is 0, so no charge. So it's something that's not combined with another element. So if it's combined with itself, that's okay. O2, H2, F2 would be an example. Or something by itself, like helium, or any of the metals that can be by itself, like iron, Fe. So if it's by itself, it has an oxidation number of 0. Rule number 2 is the oxidation number of an element in a compound is equal to its charge. So remember on the periodic table, column 1 was +1, and then +2, and then +3, and then you flip over past the transition elements, and then a little over more, and we go -3, -2, -1. That's what I'm talking about by a charge. Now, that's not true if that element's in a polyatomic ion. Only if it's combined with just one other thing, like, for example, sodium chloride here. So here's an example of both rules. Here's sodium by itself, so that would be 0. Here's chlorine bound to itself, so that's kind of like being like itself, and that's a 0. So this is rule 1. But when they react and combine, they form a compound with 1 sodium and 1 chlorine. And now we go by the periodic table. So sodium's in column 1, so that's +1. Chlorine is in that 7th column right next to column 8, right? So it only wants 1 electron, so it's a -1. So that's true if it's not in a polyatomic ion. If it's in the ion, then we got different rules, and we're going to learn that rule later. All right, so if it's by itself or combined to itself, it's 0. If it's in a compound, then it's the charge that you get from the periodic table. Rule number 3 is great. Oxygen's always -2. Now, okay, there is an exception when it's in a peroxide, but you don't need to worry about that. You're only going to worry about oxygen being -2. Hydrogen is always +1. Now, of course, there's an exception to that, like if it's bound to a metal, then it's -1. But you won't have to worry about that. So oxygen's -2, hydrogen's +1. And a good example of that is water. Here's water. It is hydrogen +1, oxygen -2. Got 2 more to go. Rule number 5. The sum of the oxidation numbers in the atom of a neutral compound, so neutral means it doesn't have a charge to it, has to equal 0. So for example, and we use the subscripts, it's very important. We can do a little math here, and the hydrogen charge and the oxygen charge here in water have to add up to 0. So if we do some math here, right, 2 times +1 plus -2, right, that equals 0. Check. What about here with my calcium hydroxide? Well, calcium is in column 2, so it's a +2. Then rule number 3, oxygen's -2. Rule number 4, +1 for hydrogen. So these all have to add up to 0. So we can check and see if we got our calcium right. So we take 2, we got to distribute this 2 here inside the brackets. So we have a 2 minus 2, 2 times -2, right, that's -4. 2 times +1, right, that's +2. Right, so I have a total charge right here, if I add these together, of -2. All right, -4 plus 2 would be -2. So that means calcium has to be +2, so it adds up to 0. Now, this is a helpful thing to do if it's something that's not in like column 1 or column 2 or column 3, like one where we don't know the charge. Because like say it was iron, say this was Fe. Then we could do some math here with our oxygen hydrogen because those have rules. Set them equal to 0 and then figure out what the number is. All right, on to number 6, our last rule. This is the polyatomic ion rule. The sum of the oxidation numbers in the formula of a polyatomic ion is equal to the charge. So yes, not only do you have to know the formulas of your polyatomic ions, but you have to know the charge, and hopefully by now you know them, because I've only said it about 100, no, maybe 1,000,000 times all year. So this one's our nitrate, right? And we can follow the rules with oxygen. Oxygen's always -2, but if the sum of all of the numbers have to equal the charge, that means that -2 times 3, right, so that's -6, has to equal -1 because the charge on nitrate's -1. So that means nitrogen's not +3, right? It would be if it was combined to, I don't know, chlorine. But if we do some math here, right, it must be +5 because 3 times -2 is -6. That is to equal -1, so it's got to be +5. So when you're dealing with an element in a polyatomic ion, we need to use this rule in order to figure it out. Let's take a look at sulfate. Here's sulfate. Sulfate has a charge of -2, and it has oxygen, so that's -2 always, right? That's rule 3. So 2 times a -4 plus something equals -2. So we can actually physically set up equations, whether we do it for nitrate or sulfate. So we can call sulfate X. And we can say X plus 4 times a -2, right, because there's 4 oxygens, each at -2, right? So that'd be a -8 has to equal -2. So what plus -8 is equal to -2? How about +6? So we can do the same thing here with nitrogen. We can set up a mathematical equation and call the unknown x and figure it out. Now, of course, if there were 2 nitrogens here, then we'd have to multiply x by 2. So this would have to be 2x. So if there's a subscript here, make sure you multiply your charge, whether it's an actual charge or it's an x, by that number when you set up your equation. All right, those are the rules. Now, on the next page, you will see these practice examples. See if you can do these. Follow the rules and see if you can do them, and then we're going to take a look at them together in class. See you soon.